Alright, here we go. Coffee is firing on all cylinders tonight, so fair warning. Um, let's get into it. We don't need to waste time. Part 1 was posted yesterday. Let's get to it and work on Part 2. Alright, here's where we left off. I just realized that I left it powered on overnight, so let's see if it's still working. It is, okay. So we didn't blow anything up. I don't know why I didn't switch that off. Or maybe I subconsciously switched it on, but okay. Power supply's still good. We get our roughly 8 volts off of CD plus and minus and our 30 volts between the two regulators, so we didn't kill anything. That's a good sign. And if it was powered on overnight and it survived, then hey, it's probably going to last. My lead's cleaned up real quick here. Try to make a little room. Alright, so we need to finish the recap on the rest of the amp and then do a test, and then I can silicone it and get this thing buttoned up. So power supply is done. I am going to bleed off the caps before setting this thing somewhere and blowing it up again. Shouldn't be a whole lot of juice in them, but just in case. Make sure they are drained. I don't worry about the little ones. I mean, you probably should. 50 volts is still 50 volts, but whatever. Don't do as I do. And probably don't do as I say either. Just watch and you'll be a lot safer that way. Alright, so this is the feature board. The RSW-10D feature board. So we're going to, replace a couple caps on here. I usually leave this guy alone. Just because it's glued on and it's soldered to a surface mount part, and I don't know, I just don't generally replace it. But the rest of them will get replaced. Maybe I'll do that one tonight too. I don't know, it depends on how I'm feeling. It's just kind of a pain working with the surface mount and getting it like bent over and cutting the glue off and not damaging anything. And we can test it though while we're waiting for the solder sucker to power on. Let's test it. Let's see if it's actually any good. If I can get in there and not short the leads out. So we're looking for around 4.7. This is I don't think any of the caps on this board are probably bad. So we got 4.3 and it's a 4.7. So it's going to stay right where it is. And it was an afterthought by the engineers anyways. I don't really know what it does, but this board generally does not take any heat or abuse. I would say if you really wanted to skimp and leave this board out altogether, I'd say you probably could do so. The only exception being I would probably do these two, just because those are the main caps for the 15 volt coming in off of this connector over here. So those are our main filter caps. The rest of them are either in the audio path or filter caps for the op amps. Like I said, these don't get really hot, so they should actually last their rated lifetime. So if you want to skimp a little bit, you can. If you don't, that's fine too. Go ahead and replace them. I'm not going to test them all. I'm just going to pull them out and replace them. And like I said, with the exception of the reworked one, I'm just going to leave that one alone. So we're heated up. Let's get to it. Let's get jamming. I'm starting a little bit early tonight. The wife is at work. She's working late, I guess, so I figured I'll get a little bit of a head start. That doesn't mean I can keep working when she gets home, but we'll see. Depends on how tired she is. She might want to hang out and chill for a little bit. which unfortunately is more important than amplifier repairs, at least in her opinion. So this is another one of those boards you gotta kind of be careful with. It's only a 2-layer board, so if you do completely wreck it, you can probably remedy the thing that you wrecked on there, but still be careful, because the microprocessor can be replaced, but the code on it cannot. I don't have the file to flash it. I might have the tool to flash it, but I definitely don't have the file. I've never tried to read one. I don't know. I've never really had a need to. Probably something I should add to my to-do list down the road, but for right now, we're gonna leave well enough alone and not break this board. So we'll give it a fresh set of caps. And usually on the RW series, like depending on how the amp looks, sometimes I will just leave this board alone. It all depends. And it all depends on what's asked of me to do. You know, I offer 2 different, I guess you would say, levels of service. One is just a basic repair, where I fix the known issues, and the other one is like a restoration where I go through and I basically recap everything after the repair. So it depends on what is asked of me. But this one's going back to Canada, so we're going to make sure that this gets pretty much everything done to it that it needs to survive the next 10 to 20 years. And that's basically because I don't want to have to pay shipping from Canada back to my house should something go wrong. Soldering tip is kind of crusty. Might be time to order a new soldering tip. Soldering tips are not cheap. That's one of the things that kind of sucks about doing this as a hobby. Like, I can't order all these parts and write them off my taxes. But that might change. I'm depending on how bad I get hit with PayPal taxes this year, since they're reporting to the IRS, I might turn it into a business so I can just write everything off. It's kind of a weird situation. But apparently, if you do operate as a business, you can basically just write everything off. Shipping, consumable parts, solder, flux. I don't know if I could write the capacitors off, the parts. I'm not too familiar with tax law, but all I know is that anything done online is going to be like heavily scrutinized going forward. Which in my blog and on my posts, I clearly state this is just a hobby. Like, I don't want it. When the hobby starts costing me money, it can't be a hobby anymore. I mean, I can put a little bit into it, but I don't want it to get to the point where, I'm paying for basically everything, and then at the end of the year, I'm just going to get slammed with taxes on all the work that I do. Like, I don't want to do that. And I can't go under the radar, because then, I don't know, they'll probably get me for tax evasion or something stupid like that. It's just really ridiculous. I don't know. Like, I basically figured out, my prices are lower than anybody else's. And it's basically because, I do this for fun. I don't do this to generate income. It's a self-sustaining hobby. Which means that if I did file my taxes, I would be reporting 0 as income, so. And everything would be getting written off. But because of these weird new laws, and since I do most of my invoices and stuff on, or through PayPal, all that stuff has to get, reported and tracked now. Which kind of sucks. I guess it doesn't suck. I just need to be able to calculate, how much I have into each board. So my time is obviously worth something, and how do I calculate an inch worth of solder? What does that cost? That's a consumable. I'm using solder, I'm using electricity, I'm putting wear and tear on my tip. For each repair, I guess, you need some way to quantify your losses on all that so I can compare that against the profit that I make. And then what about my salary? What do I deserve to get paid for doing it? I shouldn't work for free. So how does that all go in? I need to find an accountant or somebody and repair some of their equipment for some advice on how to continue moving forward. But like I said, we got a whole year to go. And depending on how much I'm screwed at the end of the year, will determine what happens next, I guess. I do know, and how do you quantify value? So, I do fix a lot of amplifiers. I paid money for those amplifiers. I have time into repairing them and cost. How do you say that I'm selling it for less than it's worth? And who gets to make that decision? I'm going to make sure I'm taking the right caps out here. I think these are all 22s, yeah. Talking too much. Too much ranting and not enough repair work. But yeah, I was just reading, the updated rules and regulations or whatever pertaining to online transactions, and the government's trying to make sure everybody pays their fair share, which I guess I understand. There probably are a lot of people that do tax evasion, but I mean, when companies like Amazon can write off their almost entire tax liability because the tax laws allow, research and development to be written off, why can't I, are they really going to benefit from getting a couple $100 from me? I mean, that's the way I look at it. Go after the big fish and then worry about the little ones. But that's apparently not how business thinking works. Let's screw over the little guy and the big guys will continue to get all the breaks. Welcome to capitalism. But anyways, back to amp repairs. No more whining. I just thought that was a pretty interesting topic. I think this guy is in there. .7, 50 volts. I don't even think that cap's needed, but we're going to put it back in there. That's the cap that goes right by the IR sensor, which is not populated on this board, so I don't really know why we need it. But it literally goes directly to the IR sensor that's not there. I guess if you have an RSW-10D and you wanted infrared on a remote, you could probably use a feature board out of RW-10D, and then you'd get the remote functionality. I don't know how much you know, how much of a need that it actually is, but I mean, subs have always been to me kind of set it and forget it. You don't need to really go bananas with them, but if you wanted to, I guess you could. Changing your settings for different music styles or whatnot. Got one more forever. Yeah, well, most of the caps on here, well, I guess there's a combination, but the forever caps are usually pretty good. They're the least trashy of all the other ones. We'll measure a couple of these. Let's just do these 3 right there. These 4. We'll see what they measure. Got a couple more of the little 10s that have to get replaced, and then we'll be in business. And then we just have the amplifier board and testing time. Well, there is I believe an analog version of this one too that uses a different board. But this is the weird one that I have to use the fancy little custom input for. Alright, since I got the cap tester out already. No, I just lost my tweezers. Let's look at a couple of these, just for some education. I want to see if they're measuring with intolerance. That one is pretty close, 44. It's within 10%. So the forever cap reads 44. The Junzel reads 22. So there you go. There's proof that the forever caps are pretty decent quality and the Junzels are absolute rubbish. Let's get more data points. So this forever cap is 44. Let's see this. Check this one too. Let's see. Where are we at there? 43.3. Still within 10%. So, let's see. Here's another Junzel. Let's see what that one reads. This might be one we tested already, but we're just going to pull it out and read it. So 36. So you can see clearly the forever caps are way better than the Junzel ones are. So, you know, if you're doing work on this and you want to skimp a little bit, replace the Junzels, leave the forevers. That would be my recommendation. I don't know if these will measure in circuit, these little 10 microfarads, but I'm just going to measure them just to measure them. Yeah. Nope, not a chance, because there's a whole bunch of other... Yeah, it doesn't even know what to do. So yeah, anytime you measure something on the board, you're never going to get an accurate reading. When it comes to a cap, resistors sometimes, typically not. This tip is not really friendly for pulling out these small ones. That, and they're probably angry at me for not diluting the lead-free solder. This little jumper resistor here, we're just going to leave him. Just bend the leg out of the way a little bit. It almost looked like that one cleared. I doubt it, but we'll check. It actually did. Well, I'm quite surprised. Junzel, 10 at 16 volts, so we'll get rid of all those. There's 3 of those things. Why they have to be so darn small, I don't know. You could have used a surface mount at this point. Tip's getting a little bit clogged. Gotta clean it out a little bit. Alright, so 3 more and then the preamp board is done. And then we will go on to the amp. Uh-oh. Uh-oh, we might have an issue here. Whew. Barely enough. So I have 2 left of my 10 microfarads. I got higher voltages, but not the 16 volts. I'll have to check my reserves and see if I have any in there, but if not, I'm going to have to order some of these. Add them to the list. Well, the reason you want to get the junk caps out of there is because more than likely, before they fail, they're going to start leaking. And once you get electrolyte on the boards, I mean, you might as well, in some cases, just throw the board away because it starts just disintegrating traces. Looks like we lost a pad on this one. I wonder if I can save it. We can, but alright, we'll be okay there. That one's going to get glued in place. We did lose the bottom pad, but the bottom pad is not connected to anything. It's just a floating pad, so you know when you put the high heat on there, they do just pop right off. It should have a through-hole repair on it, but I'm just going to hit it with a blob of silicone to secure it in place. It's soldered all the way through. I can see it. It's just a little annular ring. Like the through-hole's not damaged. I just lost the annular ring on the outside, so that will cause no harm at all. If the through-hole is damaged, it would definitely be replaced, but I don't want to drill a hole through the board and risk doing more damage for a top connection. Not worth it. Not worth the chance of hosing the board over. And all the connections are on the top of the board here anyways. Yeah, I'm not worried about that. Not worried about it. If we made connections on both sides of the board, it would definitely have to be repaired, but that will be just fine. I have spare annular rings. I could just throw one on there, but it's not going to be connected to the via, so you really don't gain anything. Just wasting time. And I'll put a little ring of silicone around the bottom there. That thing will never move. And in 20 years, the next guy can cuss me out when he goes to replace the cap. Chances are it's not going to have any issues, though. And we test, so always have to test. That's the most important part of all of this. So this guy has only 3. Only 3 caps. We have 3 caps to go, and we are going to be ready to reassemble and test. How cool is that? home stretch. I think part of the reason is this, this tip does use a lot more heat than the other tips I'm used to, but I don't know, I seem to like it better. 4.7 at 35. So you kind of got to take the risk of damaging these cheap Chinese boards. But the benefit is you get a little bit, more heat into the joint, and it clears the solder better. So you got to take the good with the bad, I guess. There's really no way around it. As long as that solder wicks through the board and you get a little fillet on the top too, you're golden. Pay attention, when you're soldering your stuff in. Don't just do a garbage job and, have cold solder joints everywhere. And, you got to be confident in your work. And until you're confident in it, you need to double check yourself. And I still double check myself a lot. And I know I do, a semi-decent job. Nobody's hit me up in the comments yet and told me I suck, so that doesn't mean they're not thinking it, but they haven't told it to me yet, so I'm taking that as a win. I think the worst comment I had was some dude overseas told me I sounded like an old grandma that smoked a pack of cigarettes. I can't really do a whole lot about my voice, but if that's the worst comment I have to deal with, hey, I'll take it. I forget the exact comment. I think he said what you're doing is cool, but you sound like an old lady that smoked a bunch of cigarettes. I got a pretty good laugh out of that. I take constructive criticism pretty well. I'm not very good with deconstructive criticism, so if you come at me with a bunch of garbage, I'm most likely going to fire back at you. If you come at me with something factual or funny, then I'm usually pretty forgiving. I don't think that's anybody, though. Nobody likes to be, blindsided. Luckily, the audio community is mostly really cool people. The only people I don't like in the audio community are the people that think that $5,000 cables make their 1960s gear sound better. If you're one of them people, unsubscribe from my channel immediately. I can show you with my cheap-ass oscilloscope that your $5,000 cables don't mean one bit of difference in your audio setup. And the crazy part is when that audio was initially recorded, they recorded it on like $32 cables. So I would love to know how your magic, super expensive, high-tech cables are better than the cables that it originally was recorded on, and how you can improve that. Especially if you're like listening to records or something, like just stop. Unless you're listening to mastered copies of lossless audio, your sound quality is not going to increase any. I open those debates to anybody that wants to challenge me with them. I'd even make an entire segment on it. Granted, I don't have a set of those cables, so whoever wants to argue that point's either going to have to bring them over and hang out for the day or send them to me to evaluate them, but I will gladly prove to anybody that's willing to learn that wasting money is wasting money. Been on a lot of tangents today. I'm in. Maybe I had too much coffee. I'm in some kind of a mood. I'll tone it down a little bit. Everybody's gonna get all worked up and mad at me. Alright, let's get this thing put back together and get it tested. So we did a full recap on the amplifier, full recap on the power supply, 99% recap on the feature board. You should be good to go. I'm kind of feeling guilty about that one cap I didn't change. I'm going to have to change it. If I don't change it, someone's going to guilt trip me into thinking I should have. I don't want to let the internet trolls defeat me, so I will probably give you guys what you want. Plus, I'm going to bet that it's one of them Junzel caps, and I don't want to leave any of those in the system. Screws that go into plastic, do not make them tight. There's no reason to. Just get them semi-snug. They're kind of self-locking because the plastic deforms. The screws aren't round. They're trilobular, which means they have like a triangle-shaped rounded profile on them, so the plastic deforms as you're threading them in. So they do stay tight, and they don't vibrate loose. Alright, yeah, we gotta cut a couple of leads here we left. Preferably not let them fall back into the power supply. That would be a good thing. Alright. We are golden. Let's screw this back in. Grab a few parts out of the box. I think I got a screen out. I'll be curious to see if this has that buzzing issue with the display, like the RSW-10 that I was working on, or RSW-12, whatever that was. No, that was a different one. That was I don't know, RSW something. I don't remember what model it was. Anyways, I'm curious to see if that carries over onto this model. And I determined on that there's really nothing you can do about that. It's just when the backlight was lit up, the speaker had like a really faint hum to it. As soon as the backlight went off, it went away. When the backlight is programmed in this software to go dim after a certain amount of time, and it can't be set to always on, so the noise, no matter what, will go away. So I just left it. Like, what else could I do? It could be that my there's something weird going on with my display. Maybe my display board needs to be recapped. But I tried it with two different ones, and they both did the same thing. So that tells me it's probably not limited to my display only. But either way, it was a pretty weird issue. Now here's something we got to check out and correct. This resistor here is touching that heatsink. I can't see if there's a trace common to it or not. Either way, I don't want it touching because I'm not sure, so we're going to just straighten that leg out a little bit and see if we can get it away from the heat. Well, here, let's just do continuity check and see. If it's touching on the circuit board, then I can leave it alone. Fire up the trusty Radio Shack meter. I love this thing. Okay, so they are connected together. Nothing to worry about there, folks. And since it's kind of early, I can actually hook this up to a speaker and make some noise with it. Piss off my neighbors who absolutely don't care about any noise I have because they have 4 kids. I could fire a machine gun in my basement and they'd be like, yeah, did you have a good night? They would literally not care. Pretty cool. Pretty cool. So when you are working on this thing, here's something you are going to need. This is a highly customized Radio Shack Y adapter that's been modified, but I just put a JST plug on it. And just for reference for any other techs that might want to be doing this, I think pin 1's on the left. Yeah, pin 1's all the way on the left here. So 1, 2, and 3 are blank. Pin 4 is audio ground. 5 and 6 is left and right. I don't know which coordinates the left and right, so I just have them connected together in mono. But it's a JST. I think it's a XH connector. Pretty common connector, and that just pops right in. So I generally don't have the owner send me the little plate that has that on there, but I have my own little cables, so I can test it. I mean, you could just scab a wire in there too, just solder it on to get your audio signal in there if you were in a pinch and you didn't want to mess around. But I just made that up to make life easier for me. It's one less thing I have to remember. And as I do say in all these, videos, when you're plugging in a display board, make sure that you have the keying on the plug correct. There's 2 notches on there and there's 2 notches on the sides. You got to make sure that they line up before snapping this down. Because if you break this connector, this J7 connector, you're going to wish you didn't because you can't get them anymore. At least I don't know where to get them. I've looked. And I've determined that if you break that, you're toast. And let's see, I think all the ones that are in my graveyard pile, I'm just kind of doing a quick little peek back here. No, I have one left. But yeah, those cannot be found. Now you can find pin headers and other things to replace it with, but it's not an easy thing to replace because there's a ton of pins on it. And it's not necessary. Just be careful when you're plugging this in and you won't damage it. Don't be a bonehead. Alright, I want to get the display in view here. How can I... Alright, that kind of works. There's no metal under it. I think you guys can kind of see that. We're going to go right to the speaker. I do have it hooked up to my scope, but I don't think that's necessary. I do love how the speaker connections on this are readily plug-inable. I can just hit them right from the edge here, and I don't gotta mess around with my fan. I like this amp. I really do. I think it's a good amp. It's nice to work on. It's compact. From a service standpoint, pretty decent amp. Alright, we're going to start off with 30 hertz. I don't know if you guys will be able to hear 30 hertz. We're getting mono. I use this cable as a plug saver so I don't ruin my really good one from, constantly plugging in and out and in and out and in and out. I think we're good to go. We just need power now. Power switch is off. Okay, current limited. We're going to always start current limited. And from part 1 of this video, we started current limited, and that's what led us to find that we had both of our MOSFETs were shorted. If you would have went full power, those MOSFETs would have probably just exploded, and who knows what else would have went with it. So, if you're doing this kind of work, you got to have a current limited supply. No more than 1 amp. I mean, 500 milliamps would probably be preferred, but sometimes you need up to 1 amp to charge some of the caps in the power supply stage. But here we go. Current limit, Power, actually, wait. We almost committed a sin here. No audio connection for first power on. That's a rule too. Alright, here we go. So power is on, but we get nothing. But we did get a blink. Let's do that again. Current limit power on. We're going to wait a few seconds. Power off. Flash. So when you see that flash, I know right away what it is, and our voltage regulator is bad. I know that from experience, so I'm trying to share that knowledge with you. Our 7805 here is gone. So this is probably, you know, a Chinese 7805, so it's like a 7804.8 or whatever, 780 something, whatever it is, it's not doing 5 volts anymore. There's a right way and a wrong way to get this off. I'm going to show you the right way, and I'll let you guys figure out the wrong way, but I'm going to take my cutters. Let's zoom in on this a little bit. Why not? I have time and I'm able. I'm trying not to unplug the power. But, so this is the guy we got to take out. And I know it's not perfectly focused. The camera's going to keep freaking out as it moves. But I'm going to take my cutters and I'm going to set it like on top of the pad there. And I'm going to push down and snip at the same time. And the reason that I'm doing, and I'm cutting above where it's soldered. The reason I'm doing that is when I cut it, I want that leg, like you saw the package break there and the leg popped up. That's what I want. I want the leg to break on the device. I don't want to rip the pad off the board. So it's kind of critical to do it this way. And by pushing down like that, you're guaranteeing that you're not going to rip the pad off the board. And these boards are cheap. They're made in China. So the less you can stress them out and damage them, the better off you are. And who cares? This device is already bad, so if you break it, big deal. This is already broken to start with. You're not really doing anything worse. And then to get the actual device off, I'm going to heat up the solder sucker again, but what I do is I just put a big blob of solder on the heatsink. And when that solder actually flows in to the heatsink, the device should be hot enough to pick up. You get a pretty big ground plane under there, so you know it takes a little time, but there it goes. You can see it loosened and came right up. That's the board saving way to do it. There's other ways to get it out. You can use hot air, but you got to put a decent amount of hot air into there, and it usually messes up, you know, everything else on the board. So I've kind of gotten away from doing hot air on almost everything. I just really can't see a reason to use it. Now this you could do wick or you know, a little vacuum hand pump if you wanted to get it off. That would be acceptable. I'm just going to use the solder sucker because it's faster. I'm clearing one of the pads off. You can leave the other pad that's by the capacitor. That one doesn't need to be cleared. And now we got to find a replacement. I stocked up on these bad boys because I was worried they were going to go obsolete. So multiple things wrong with this amp. You know, this thing took some, I don't want to say abuse, but it definitely took a hurting when whatever event killed all this stuff. Now the 7805 that I'm using, this one is by ST. It's a quality part, and it should provide a good service life to it. I'm going to dilute the solder on this one pad, put a little bit of lead in there. It'll be like a hybrid. And then just use the tweezers, and we're going to solder down one leg. I think I've showed this before, but get the device as centered as you can. Doesn't have to be perfect, but you want it to be good. And I try to leave as much area at the top of the heatsink as I can. Alright, so the device is down. I solder both legs. You know, I push the device onto the board too to make sure it's flat to the board. And then I solder into one leg, then I'll go back and resolder the other one. Put a nice big blob on there, that helps with the heat sinking. And then I go back into the heat sink and try to flow some solder into the heat sink. And you'll be able to see it flow. You want to make sure you get a good flow through there, and then just wash it in. And what we're doing is we're trying to make sure that the solder wicks its way under the heat sink, and then put a fillet on the top to make sure that we can have the device be nice and secure. So that's the proper way, what I would say, to do that. Whether or not, I'm sure other people have other ways of doing that, but I've ripped enough pads off to know that this is the best way to do it. Now, if you do rip the pads off, I recommend going to the through-hole version of the 7805, and then you can just bend the legs around to reconnect, where you need to go. Or you can solder the surface mount on there and then just use some little jumper wires to correct your mistake. So it's not the end of the world, but if you follow the steps that I showed you, you won't have any problems. Alright, no audio. No audio. We gotta get this beast powered on first and make sure that our volume levels are not set to shatter the windows, which they almost always are, so. Alright, make sure we have nothing risking shorting us out. Current limited, here we go. And we have power. So when you see that little flash of the screen when you turn the power off, right away, that's your 5-volt regulator. Now, this one was set to mute. Awesome. I'm going to go through the settings and change them all to what I like to send it out as. I always go flat. No equalizer in there. LFE mode, so we're not cutting off frequencies. Phase to 0. One of the reasons I do that is it forces whoever has it to retune the sub to their environment. And the other is so I get consistent results when I'm looking at the waveforms if I have to look at it on the scope. But with the recap in there, the sound, might be a little different. The phasing might be a little different because the values are going to be different. The amp was being used with capacitors that were way out of tolerance. So when you put parts in there that are back in tolerance, it's going to change the way this thing sounds. Hopefully for the better, but let's see what we got here. Oh yeah, there we go. There's 30 hertz. It sounds pretty damn good. Let's visualize while we're working on it. I put a oscilloscope probe up there and left it up there so I can hook it up to the little Quemot here. Or QUI, I don't know what the hell this thing's called, but the battery powered cheap scope. I love this thing, by the way. This is one of the best things that I have here. There it is. That is about as good as a waveform as you're going to get. It'd look even better on a good scope, but it looks pretty darn nice on this one. Showing 31.8 hertz. If I increase the resolution up a little bit, right Well, almost right on the money, 30.5. You can't expect a $12 device to be very accurate, but it does have a pretty good wave on there. I like the way it looks. I'll run through the frequency range here a little bit. I don't know if you guys can hear that, but we'll run through the range. You can see I'm increasing frequency here. Probably can start to hear it now. And we hit current limit there. That's why it freaked out. So since it's working, I'm going to go to full power, which I can do on the fly. 100 hertz. 100 hertz looks and sounds good. And we'll back it back down. My favorite frequency, I don't know why, is 38 hertz. I like the way 38 hertz sounds. Just like kind of a nice 38 and 24. 24 usually doesn't play on a lot of subs, but let's see, we're at 20 hertz right now. Still pumping. 19. It's rolling off pretty good now. The amp's rolling. The low frequency cutoff is hitting. But I mean, 14 hertz, we still have a little bit there. Not much, but yeah, about 10 hertz is about the bottom limit where you're going to have any cone movement. 20 is where it really starts to kick in. So I'd say between 20 and 100 is the sweet spot for this amp. But it looks awesome. Sounds awesome. So we got another one resurrected. Can't beat that. Looks good and sounds good. So I'm going to set the volume. I always set the volume down to negative 32. I can't see that. The backlight's just drowning it. I should get one of these screens that lights up the letters instead of the back of the screen, so it'll actually show up on the camera. But yeah, volume at 32, and then we'll power off, and that locks the settings in. And this is pretty much done. So I got to put the silicone in, secure the caps in place that need to be secured, and then shoot the owner an email and let him know that his amp's been repaired, and send him a link to this video. Yeah, I always like seeing the reaction, when you show somebody actually the work that you did, and because not everybody's electronics and technical savvy, so it's always nice to hear the comments and reactions from somebody when you've resurrected a piece of their gear, and they genuinely appreciate what you're doing. So not that anybody else doesn't, but it's still a nice feeling. Means I did my job. But yeah, this is RSW-10D brought back to life from what I suspect was a lightning spike and some issues. So I'm just getting everything unplugged and put back away. Pretty good amp. One of the nicer ones to work on. But alright, I'm gonna get cleaned up here. It's 11:30. We got some time. Wife is still at work. I gotta give her a call and find out when she's coming home. That's too long of a day. 12, 14-hour days. That's I gotta put my foot down eventually and say get out of there and come home. But I might get into another one. I got another box here that came in, so we'll see. If I'm not gone too long, I'm gonna eat something too, take a little break. So if I'm not gone too long, I'll come back. I think the next one's gonna be like let's see. I didn't list the model. It's gonna be an R11X series. I don't know exactly which one, so it'll be 112SW, 115SW. Could be a 110. Those are really not as common. I think those were like the Costco versions. But if I can get back and I have the time, we'll get into that, and if not, then we'll start on that one tomorrow. But I'm really trying to. My goal is to do an amp a night. If I can do an amp a night, I'd be good, or an amp every other night. I'm really trying to get caught up on that list that I know is really long. So yeah, we'll see you on the next video. Like and subscribe, and hopefully I'll be back again tonight. Thanks for tuning in.